Got a PS5 today with no power, so I'm hitting the power button. Nothing is happening. So let's go ahead and open this up and see what it looks like on the inside. All right, let's see if we have good power supply. Start with and we do have 12 volts coming in, so that's kind of good news. Now the rest of this is going to be a little hard for me to see. See, I'll try to do it without going into the microscope. A little tricky. Okay, we got our 5 volts here. Alright, we had our 5 volts here. We need 3.3 up on this coil, which again, it's going to be a little tough for me to see this. I'm going to have to get under a microscope. Let's see. Yeah. Okay, I think we're going to need 3.3 volts up here, and I'm not seeing it. Although, yeah, I'm seeing 3.3 there, so that's interesting. All right, we should have 3.3 over here. Let's see. We should have 5 volts here at the top. And we should have 3.3 right over here. And I think that is probably going to be our problem. We're missing 3.3 volt rail. So where does that need to come from? Alright, so it's going to be, I'll do this under the microscope most likely in a minute. But just so you can see, that 3.3 volt rail that we're missing is actually going to be a problem, because if we put our meter on here in diode mode, we are going straight to ground. Oh, no, that's kind of off the camera a little bit, so. Alright, so that is not normal. If we're supposed to have voltage here and we have straight to ground, then obviously we're not going to be getting any power. So we need to figure out where or what is causing that to short. Alright, so here's a slightly better view of what I'm looking at. And basically this, let's see, let's put this in, I'll just put this in continuity mode so you can hear it. So if I put my black probe right here on ground and I touch this foot right here, that's not supposed to be beeping. So we should not be going to ground right here. And that is for our 3.3 volts, which coincidentally also goes down here to where the power button connects. So we don't have 3.3 volts here either, although it is not shorted. So let's get this thing focused. Okay, so this is for where the flex cable for our power button plugs in. And when I had it plugged, when I had the power supply turned on, or plugged in any case, we're supposed to have 3.3 volts either here or here. I'm pretty sure it's here, but there's no voltage whatsoever coming down here. However, there's also no short on any of these. So what that means is that that 3.3 volts goes through something else before it gets here. We do have a ground right on the end there. So what I think is happening, because again, sometimes we kind of have to guess if we don't have all the information. I do not have any schematics for this thing. That would certainly be helpful. But I assume there are 3.3 volts that needs to be getting here. My guess is that if we start just in close proximity here, see this is shorted, but this component does not go to ground anywhere else. This one, however, goes to ground right here. So if this is bad and it's allowing this to get to ground, that's a problem. Or if this capacitor here is shorted, that could be a problem. Be lucky if it's something that easy, because beyond that, before we start injecting voltage and looking for heat, which is sometimes challenging on these boards, I think we're going to start with this area here. I'll remove the cap first. Hopefully that'll make the short go away. If it doesn't, we'll pull this off, and if that doesn't work, then yeah, we start shooting 3.3 volts in to see if we can find the problem. I was hoping that would stay in one place. I just bridged it, so we'll stick this over here in the flux. Clean this up. That's going to be a problem, for sure. Boy, these things take some serious heat. Alright. Just for testing purposes, and of course we are still shorted, so let's move this thing off. I'm going to get a little more leaded solder on here to make things easier. Right, let's not lose this cap. And we still have a short. So it's not this and it's not that. And And what I'm going to do is set these aside, install a jumper wire there, and we'll put our 3.3 volts in and hopefully find some heat. Put these aside so we don't lose them. Okay, so we appear to have gotten lucky on this one. I hit the button. I look very closely. Right over here. I got something lighting up. So let's get this under the scope and see what it is. Alright, so hopefully the audio picked up when I was using the thermal cam, but if not, over in this vicinity, to the left of F7002, we've got some heat somewhere. I'm going to try to see where that's coming from. We'll use some freeze spray so I can get it under the camera. Hopefully, we'll be able to see it. And there it is. That little dude in the top left-hand corner appears to be the problem. So that's going to be this guy right here. So apparently a 3.3 comes over here as well. Let's go ahead and take this off and see if that clears our short. We should confirm this thing is beeping, which I'm certain it is, but let's double check. Yep. Alright, so this guy's got to go. And I don't know why it is, but it seems like my luck is always the small caps that fail. I don't know why. Maybe that's totally random, but I feel like there's a pattern. Always the tiny ones. Alright, let's get some of this moisture off. Remove this, and hopefully that will clear the line. Alright, let's see what we got here. Back to diode mode. And that is ground. And that is now 3.14. So if we go back over here to where we were originally looking, keep my fingers crossed here. Red probe on ground, and we are back to 3.317. So we did relieve the short. Now the question is, what is the value of this cap? Small as it is, I don't know that it's important, but I really do like to put things back to the way I found them. So fortunately, I have a donor board, which I believe it's an EDM20. This is an EDM10, slightly different, but hopefully it has this same capacitor available, because if not, I'm going to have to do some research and figure out what goes here. Meanwhile, we'll go get our other stuff installed and cleaned up. And this, of course, oh, by the way, I'll put this in continuity mode and expect it to beep. And there we go. That is our bad guy right there. So So this does us no good. Throw that in the trash. And then, yeah, we'll get this prepped, ready to go for our new cap, which hopefully we can find. Good enough. Okay, while we're at it, I'm just going to add leaded solder, get rid of this factory stuff, make things easier. Yeah, probably could have just set that down and soldered afterwards, but either way, works. And we've got to heat that cap on anyways, so that's ready to go. Alright, fortunately, it looks like our EDM20 board has the same circuit. Everything looks identical here, so I'm going to be able to take this cap. I'm going to do two things. I'm going to take this cap off of our donor board to move it over to the one that I'm working on, but on top of that, I'm going to attempt to measure the capacitance of this, and I hope everyone does this. Whenever you work on a motherboard that has no types of schematics available, if you can, and it's convenient, and it will be now, go ahead and measure. We know this is a 3.3 volt line, so we know the minimum requirements for this cap voltage-wise probably be slightly above that. It's probably going to be like a 6.3 or something like that, maybe a 4 volt. I don't know. But you know, the higher you go, the safer you are. It's not gonna make a difference once you reach that minimum. The question is, what is the capacitance here? And I don't know the answer to that. And these things can be difficult to measure, but I'm going to try to figure this one out, record it, and hopefully somebody will make a logbook somewhere for PS5s for things that we already know for sure. These little caps are also very easy to lose, by the way. I'll try to avoid doing that. Alright, I'm going to leave that right there for a second because getting these between probes is a pain. So now that we're disconnected on one side, we should be able to measure the capacitance just by touching each side with the probe. Then once we do that, we'll get it off the rest of the way. Alright, so let's see if we can figure out what the value of this guy is. Okay, so that looks like... wish my meter was in a different position. That is 0.8 microfarads, I think. I literally can't see it from here. Yeah, okay. So that is roughly 0.834 microfarads. Alright, keep that on the tweezers. Almost underneath, that's everything that we want to. Alright, I think that'll be just fine. Give it a second, get some of that excess solder off, and then we'll be ready to test. Alright, clean this up, and I think we are ready to go. Hopefully. Fingers crossed. And now the moment of truth. Where's my power cable? Okay, let's make sure this is on. Plug it in. And with any luck, we got a beep. And I don't have it plugged in to the HDMI port, so that would probably be helpful. And it looks like we are booting up. As you can see, it shut down in the middle of something. That's probably when that cap went bad. but I think we have success. And there's our PlayStation. We'll go ahead and test everything else out on here, but I think we are ready to go.